Okay, good morning. We are going to have today, our first lab experiment for the second semester already. So for our Physics 2, we will perform today lab experiment 1, which we call as Coulomb's law. And we will have some objectives. And let's see the template that we will use. However, this template will simply be our guide because we are going to have instead a a lab presentation. So when we perform this one. Okay, so let's check the simulator. So let me share the screen for the simulator. So here is a picture of our simulator. So in your canvas, guys, you can click the link there for the PhET simulator and you will eventually be drawn to this site. And eventually kindly click the link there. You will see the loading of the site there. Now, our PhET simulator, so it has to load first. So I actually loaded this earlier. Now again, we will test the Coulomb's law principle here. So for the Coulomb's law, you can click the macro scale, and then you'll be shown these two figures here, which is our charges. So you can actually vary the distance between the charge. So this will represent our distance. And again, in our table, we call this as R. So R usually represents the mean radius, or the mean radius of curvature, or the mean distance between the two charges. So this is our Q sub 1 and Q sub 2. The value or the amount of charge is represented by this 1. So you can see the value there. When it's blue, it's a negative charge, and when it's red, it is a positive charge. So you can slide this button here. Going left will make it negative, and going right will now make it positive. So in our first set of data, we will have an increasing value of our charge. So we will increase the charge, however, we will keep the distance the same. Now, to be able to measure the distance properly, I think we have to set this marker here to 0, so we can easily identify how far is our second charge from the first one. So if I place it here, so I have here 3 centimeter. So, but your group has to decide what distance you're going to choose. Now, the next thing is you are going to record the force. So the force is either repulsion or attraction. So when attraction, when you have a reverse or a negative charge here, so they will now tend to be attracted to each other. So the arrows of the force are inward. Now again, you can either choose which of positive or negative value. But however, our main concern is to just identify the magnitude of our force. So you will have for the first set an increasing value of the charge. So you will either slide this from 0 to the right, or you will slide this from 0 to the left, increasing the magnitude of our Q. So right now I have a negative 9 microcoulomb, and I have a positive 8 microcoulomb. So what you will write on your table is simply 8 and maybe negative 9, because it is already indicated as a microcoulomb value. So right now you can set the distance at 3 centimeter. So 3 times 10 to minus 2 if the unit is in meter. Now what we want to do is to merely record the given force. So our goal is to increase the forces. So to increase to increase the charge. So the charge from trial 1 to trial 5 has to be in an increasing manner. So what happens when we increase the charges? So from trial 1 to trial 5, you will have to see to it that Q1 and Q sub 2 will have an increasing different values, no? So it's up to you, no? Now, for the next set of data, no, you will decide what charge you're going to use, and then keep it the same, and this time you have to vary the distance, no? So that's 0, and then again, no, you can increase the value here. So if supposing we are somewhere around here, no, then maybe you could probably say that this is around, no, 4.5, no, 4.5 centimeter, no? So that's somewhere around 4.5. So this one may probably be around 4.3, no, 4.3, no? So you can again, no, use the ruler there to determine the distance. So this is R, and then again, this is where you get your value of the charge. So you record simply the magnitude of our force F. So that's the basic use of our simulator. And again, going back to our template, so how do we go to what will be, what are we going to see in our template? So our experiment again, which is about Coulomb's law, and a while ago we just saw we saw the presentation there, or the simulator. So it's about Coulomb's law, and again, this is the objective, to verify the principle that governs Coulomb's law. So with the use of that simulator that we've seen earlier, which you can also click in our canvas, then you can study it. Now for your diagram here, you can use our picture there. You can get a snap of one setting that you set for your group, and attach the maybe the edited or the cropped image. So for the diagram, now for the presenter, probably you can explain the parts of the diagram. So to those who will eventually make the final video output, then you can have the diagram here and explain the portions of the diagram. Now for the procedure, how you eventually gather the data, so you may as well record it and explain how the data was eventually gathered, based on, of course, this demo. And of course, maybe there is a little difference there, because it may be a little bit different on how you understood actually and how you perform it. So based on how you perform it, you may explain the procedure. And now in the gathering of the data, you will now increase. So for this set, letter A in your table, so as I've said in our demo, you can increase the value of Q1 and Q2 by sliding the button to increase the magnitude of the charge. So sliding right will make the value of the charge more positive, with a greater magnitude of charge. Sliding it to the left will make it negative. So the force may either be plus or minus, depending on what setting you have there. Now again, you will realize that what we will eventually record are simply the answers of F on the simulator. So our goal again is to increase Q1 and Q2. Your group has to decide what values you're going to assign. But for our R, or the distance between the charge, you have to maintain this for this first set. So distance between the charges for this set, trials 1 to 5, will be the same. So you will simply jot down the value of F. So for this experiment, there's no solving. We will no longer use a formula and solve, because although we know the equation for Coulomb's law, we will not solve anything anymore. So that's the first set. So the values here is empty, so your group can write it down. Now for your letter B, no, the amount of the charge will now be held constant. So your group will determine, no, the number of microcoulombs that you will set, no, but however you will keep it the same, no. So Q1 and Q2 will have the same value from trial 1 to 5. I'm not saying that Q1 is equal to Q2. You may have a different value for Q1, another different value for Q sub 2, but you have to keep Q1 all throughout, no, the same. This just like the value that you assign for Q sub 2, you have to keep it also the same for this set of activity. Now, what will vary this time is R. No? You will have to maybe assign a value of R. Either you set R, no, in an increasing manner from trial 1 to 5 or in a decreasing manner. No? So it's up to your group as well. No? So, but as long as, no, again, there is a consistency, no, as to whether increasing R or decreasing R. No? Now, the corresponding result to R will be your recorded value for F. No? So do not forget to record F every time you vary the value of R. No? So the difference of the two sets of expression. Now comes your discussion, observation, analysis. No? Now, what is discussion again? Discussion is about, no, it is about the principle, the theory, the principle, the theory, the law, no? What is Coulomb's law all about, no? Or in a different experiment, what is that governing principle, no? So you have to identify that. Maybe you get it from a book, and you may now call it as your discussion, no? Or you jot it down, no? And present it, no, in your lab presentation. The same is true when you gather the data here. What did you observe, no? What are your visual? What did you see, no? And maybe, no, if there are other senses that you are using, no? So, but basically for this one is an observation, so we use our sense of sight, no? Now for our analysis, no? So our analysis will either be, no, we can break down our analysis in 4 different ways, no, whichever is applicable, no? So first one is to identify the things that really, no, stand out, either the highest value, no, or maybe the lowest value, no. So when you point these things that really, no, are extremely high or low, that's analyzing, no. Another way to analyze is when you compare, no. What makes the two sets of data the same? What makes them not similar, no? So when you point that out, no, that's also another way to analyze. Or you tell about their difference, no? Differentiation, or telling their contrast. You contrast one data to the other, no? What makes them different from each other, no? So that's also a form of analyzing, no? And last, and probably, no, one of the common methods also is when you graph and you see the relationship of two variables, no? What happens to the variables? Are they directly proportional or inversely proportional? That's what we call predicting trends or pattern, no? So based on your sets of data, how are they not related to each other, no? So predicting a trend or pattern is also a form of analyzing, no? So in 3 separate paragraphs, you may write your part 6 here, and eventually, no, in relation to the analysis and to the objective, you may now be able to draw your final conclusion, no? So in a statement, create your final conclusion, no? Now you may see part of the activity there, no? The rubrics, how you will be graded for this one. But again, no, the submission will be either uploaded to your YouTube, no? Which I suggest it should be better in YouTube. Although you can do it also in your Google Drive, no? But make sure the Google Drive is properly shared, or else there will be difficulty in accessing it, no? But YouTube, no, is a good way to upload the final output, no? And then connect the link, no, of your lab presentation. Now for your groupings, we will call the groupings here as Einstein, or whatever groupings your teacher may assigned to you, no? So hopefully the activity is made clear, and enjoy your first activity, no? Activity number 1.